Good morning, ladies and gentlemen. First of all, thank you for inviting me as a presenter to this valuable conference. My name is Eun-Hyun, and I'm Senior Sales Manager in charge of waste-to-energy business at Posco E&C. Today, I would like to share our experience in waste treatment under the title of Technical Challenges and Alternatives for Waste Management in Korea and Europe. Here is a brief outline of my presentation today. It has 4 main sections. Now let's move on the first part of the presentation. Now let me briefly introduce our group. Posco Group was founded back in 1968 when Korea just started to accelerate economic development. Posco Group was a state-owned company at that time and contributed greatly to the national development of Korea. We have several key business sectors such as steel, engineering and construction, new materials, general trading, energy and ICT. The annual revenue of our group is around $61.1 billion. Okay, when it comes to the waste-to-energy business, Posco E&C is a leading EPC player with a strong track record. Posco E&C is the first Korean company who carried out full EPC works of waste-to-energy plant in Europe. We also have diverse range of waste-to-energy technologies such as grate firing combustion system, fluidized bed type incineration, pyrolysis gasification, and anaerobic digestion for the organic waste. This is our global network. We've been working in more than 40 countries all over the world, including Asia, Middle East, Africa, and South America. Now let's move to our technological capabilities. The most important thing which we should consider when treating the waste is the emissions, because we must not produce another pollutants to remove waste. Although each country has their own emission standards, EU standard is typically acceptable and preferred standard in the world. If you see the regulations between Korea and EU, they generally share similar limits. In both countries, the emissions shall be carefully controlled by up-to-date flue gas treatment system. According to new directive, EU is tightening up on emission standards for the plants newly constructed. It will be more tightened in the future. Especially the carbon emission will be strictly controlled. If you see the guarantee value of carbon monoxide in our project in Europe, which was completed in 2016, was max 45. However, it became max 25 when it comes to our second project in Europe started last year. This slide shows the flue gas treatment system applied to Krakow waste-to-energy project in Poland. We adopted multiple cleaning systems such as SNCR, semi-dry reactor, dry reactor, and backfilter to meet the guarantee value. Warsaw waste-to-energy plant, which is under construction now, has the tightened guarantee value for emissions, especially in hydrogen chloride, SOx, and carbon monoxide. This is case study for our project in Korea. We also adopted multiple cleaning systems such as SDR, SCR, backfilter, and activated carbon. RDF fuelization has many advantages. Through multiple sorting systems and crushing, we can produce fluff type RDF which has relatively high caloric value and less emissions. It also is for storage and transport. This slide shows the fuelization facility we constructed in Korea. Through this facility, 900 tons of waste were treated daily and produced more than 600 tons of fuel, which do not contain crinoline, food, PVC, etc. In this project, we adopted optical sorting machine to sort PVC automatically by optical scan. In case of short-term storage, RDF will be stored in the storage bunker for homogenization and will be supplied to the thermal treatment system. If we need to store RDF long time or transport to another place, it is good to process RDF by compression and packing. In this case, we can reduce the volume by 1/5. So after the fuelization of municipal solid waste, we could have various options in thermal treatment. In case of our project in Korea, we chose circulated fluidized bed-type combustion system to produce energy. This CFBC boiler has stable heat recovery of long-time operation. Another technology for waste treatment is pyrolysis and gasification. This is flow diagram adopted in Goyang Waste-to-Energy project in Korea. In this melting furnace, the waste will be combusted in high temperature with auxiliary fuel. So there are 3 zones started from drying, preheating zone, and then thermal decomposition zone. After that, combustion melting zone in higher than 1000 degrees Celsius. Even though pyrolysis and gasification has several advantages, we do not recommend this method because it is relatively expensive and very sensitive to control and operate. Instead, we highly recommend the conventional type, which is great firing combustion system, because it can have large treatment capacity and satisfy large variation in waste composition and calorific value. This is the comparison table for the various combustion technologies. As I explained, the great firing combustion system is highly recommended in your projects in Algeria. Now let's move to our experience. This slide shows some of our experience in large-scale EPC projects all over the world. Those are our major power projects in domestic market, including waste-to-energy plants. Those are our projects in Europe. Krakow waste-to-energy plant was already completed in 2016 and under operation successfully. It treats 220,000 tons of waste annually and is producing more than 10 megawatt of electricity as well as 35 megawatt of thermal energy for district heating. On the right side of the slide, you will see Warsaw waste-to-energy plant under construction now. It will be completed in 2024. This is newspaper article published in Poland. It says Posco E&C is the only company who can complete the project on time, compared with other ongoing projects started simultaneously. This is very interesting point. Waste-to-energy plant shouldn't be an unpleasant facility to the public. So the concept design of this facility was established by a design contest among citizens of Krakow. As you can see here, it looks like an art museum and it was awarded Poland's Building of the Year in 2016. Until now, many citizens and students are visiting this plant for the field trip and tour. Those are projects in Korea using ALDIA fuelization and CFBC boiler. Those are our projects using pyrolysis and gasification system in Yangsan and Goyang in Korea. This table is our references in waste treatment and waste to energy. So this is Algerian project we are looking at this moment. Actually, Posco ENC participated in the feasibility study together with some Korean engineering firms back in 2018 in cooperation with KT, which is Korean government, and AND, which is Algerian government. Hopefully we could have chances to participate in these valuable projects and others planned in the future. Now let's move to the last part of my presentation. Currently, all of us are living in an era of decarbonization. Renewable energy and eco-friendly treatment of waste are essential and inevitable trend for international community. EU emission standards are getting stricter, so you need a right partner to develop a new waste-to-energy plant. This is another challenging and possible solution adopted in Korea. To avoid opposition from civic groups and residents, we built the waste-to-energy facility underground. It was installed 25 meters underground together with sewage treatment plant. And on the ground, as you can see here, a park and sports facility were created for public welfare and convenience. We believe this is one of possible solutions for the NIMBY phenomenon if we build waste-to-energy plant in the downtown area or new city. Also, in Korea, especially in the new cities, recently developed ICT-based waste management system were adopted. For example, our head office is located in Songdo New City in Korea, and there is no waste truck going around in this city's downtown area because the automatic collecting system is installed underground and there are waste drops in each building which transport the garbage into waste station by vacuum system. The collecting data is monitored by Ministry of Environment of Korea in real time. This should be considered from the design phase of new cities and be installed the underground facilities before the construction of buildings and superstructures. This is the end of my presentation. Thank you for your time and attention. I wish you a very successful development through this conference. Thank you very much.